for Tech Noida. He's working as a tester and test automation architect with QA Infotech since 2004 as a senior manager, quality engineering, and head of the test automation group. He has worked on a various set of manual testing and test automation efforts, many areas of expertise including test automation using open source solutions, testing application management technologies, localization testing, web services testing, and application APIs testing. And he plays an active role in the company in enhancing the test automation solutions, evangelizing them. Besides being an active practitioner, he is also an active speaker and presenter at software testing conferences around India and other areas, and he is a very good trainer too. And he has a bachelor's in engineering and information technologies at Bangalore University, Gujarat, India. Over to you, Ramandeep Singh. Same thing applies. 20 minutes, 5 minutes for question and answers.
Thank you.
Great.
Good afternoon, everyone. It's right after 12 o'clock, so it's safe for me to stand up here and speak. Okay. The end user experience, the real end user experience depends a lot on the performance of the application UI. Traditionally, when we want to measure the user experience of an application, we would look at the load test results and determine and do an analysis from there. But for the modern day applications, the kind of applications that we are seeing on a daily basis nowadays, which have very complex UX workflows and interactive and rich UI, user interfaces, the user experience is a lot more than just the HTTP performance of the application. In fact, the user experience incorporates the in-browser performance of the application as well. The browser render time. The time the browser takes to render the application client-side code. How would we incorporate that in our overall picture of the user experience? So the question here is, how do we do in-browser user experience profiling? At Q Infotech, through our rigorous research and development, we have been able to develop some open source solutions which were built on top of existing open source solutions with which we are able to do user experience profiling. And today I'm going to demo some of those solutions with which we are able to do application profiling to measure end user experience. Let's have a quick look at the agenda. I would first talk about conventional performance tests and realistic user experience to try to understand what the real problem statement is. Then I would demonstrate some of the solutions. I hope I'm audible back there.
Yeah.
Then I'll demonstrate some of the solutions that we have developed, and we'll try to see how we are able to do UX profiling using these solutions, open source solutions. Then I will talk about why all of a sudden, in the present scenario, this has become more relevant to do in-browser user experience profiling. Then we would look at how we can implement these solutions that we have built as a practical solution in your day-to-day testing cycles. Let's try to understand the problem statement in a bit more detail. Consider any web applications. The user, the end user trying to access the web application would use a web browser. And internally, the web browser would invoke a bunch of HTTP requests to the application server or the web server, and you would get a response in the same HTTP transaction. It's the responsibility of the browser to render the data that is available from an HTTP transaction into a UI that can be presented to the end user for an interaction. That UI is your web UI, the web pages. And when the user interacts with those web pages, it's again responsibility of the browser to capture those interactions and convert them into subsequent HTTP requests and responses and redraw the UI according to the interactions. In a conventional load test scenario, any existing load test tool, whether it's a commercial tool or an open source tool, the load test tool acts as a simulation of web browser. That means when you want to record a test, the tool would intercept the HTTP transaction between the browser and the web application server or the server. And when you want to run your load test, the tool would just play back those transactions, check for the responses, capture the response times from all those transactions, and prepare a load test analysis based on the response times of these interactions between the browser and the server. But what about the browser render time? The time that browser is taking before it presents the information that it has to the end user in a user interface form. Browser has to do a lot of computation and a lot of calculation in order to render the HTML and JS and all the other different plugins that we have to present the UI. So how does we actually measure and incorporate that render time in our overall user experience profile of the application? The answer is we can do this through test automation. And in fact, at QAIT, we have developed some solutions using which you can do in-browser user experience profiling, and these solutions can go alongside your existing load test tools and the overall analysis. Let's first straight away dive into a demo and see how it happens. What I'm going to do is I'm going to run a small test, and this test is for Yahoo Finance page. What would happen is browser would launch, which was just launched, and the browser would open Yahoo Finance page. I think it's taking a lot on because for some reason my mobile network in these walls are a little slower. So maybe I'll just play the video. Let me not rely on the demo. You know, demos they never work when you want them. So I'll just play this video. So what would happen is the framework or the scripts that we have written, it would open the Yahoo Finance page, record the time the browser takes to completely render the page. Then, next set of activities would be performed, which is searching for a particular schedule. And then, the scripts would also record the time it takes for that activity to be completely rendered on the page. So essentially, we are timing two different activities, two different user activities for this particular application. And this would happen for multiple different iterations because, you know, when we are computing data and we're taking readings, it has to be number of iterations so that we can eliminate errors. Once it is done, it would do the same thing for another browser. So we have comparative data for two different browsers. While this is happening, let me straight away just go to one of the reports that we got from the execution of these tests. So this is the kind of report that you would see from the execution of this test. There are a bunch of graphs, and the first column, as you can see, is the graphs, the readings of execution of this test on Google Chrome. And the second is for Firefox, essentially on the same machine, two different browsers, same set of actions, readings on two different browsers. In the graph, you can see that the x-axis is the number of iterations for which the readings were taken. And I'm so sorry. Let me just open this up. The x-axis is the number of iterations for which the time was recorded, and the y-axis is the time it took for the browser. Now there are two different set of readings, the red line and the blue line. As part of our solution, we have built some extension to the framework that not only just capture the time, record the time inside the browser, but would also intercept the HTTP transaction taking place between the browser and the server while those activities were being automated by the tool. And it would present the time of those transactions in form of these red lines. So the red lines are the transaction time of the HTTP transaction, the response time of the HTTP transaction for one set of activities that was performed by the user. The first activity was obviously opening the page. And the second was performing a search or probably going to the login page. And the blue line is the time recorded inside the browser through the automated scripts. So we now have two different times. One is the HTTP transaction time, the other is in-browser time. And by difference, we can straight away say that the difference of these two would give us the render time, the time that browser takes to compute and render the information provided to the end user. Right? I just hope this graph opens up because I wanted to show a lot of stuff in there. That's okay. I want this graph.
Come on.
Anyways, so what essentially you will see in this graph once it opens up is that for Yahoo Finance page, the page load time and the render time, there's a difference in the two browsers, Firefox and Google Chrome. Compared to Firefox, Google Chrome takes far less time. And that is primarily because the way Firefox is built, but also because the way the client-side code of Yahoo Finance is built. It's the responsibility of the developers to optimize that code so that the performance of the client-side code remains consistent across all different browsers. In fact, we did the same execution on a second machine, and this time the machine had only 1 gigabyte of RAM. So what we did was we reduced the amount of memory that is available for the browser to perform its set of actions. And this time we get even more conclusive results. The browser render time, which was earlier averaging to about 1.8 seconds, grown to about 2.1 seconds. So there was about 300 milliseconds difference. Now let's get back to presentation. Now let's try to understand why in the present scenario and the kind of application that we are seeing today, doing such kind of an activity is very important and more relevant. Couple years ago, not couple, almost 15 years ago, we had Web 1.0, with which we were able to develop basic HTML-based applications. There was basic HTML, basic user interaction, some level of JavaScript. And in that case, the responsibility of the browser to properly render the application was far smaller. These are all the set of activities that are supposed to be done for the application to be delivered to the end user, a web application. And you can see in case of Web 1.0, all these tasks fall into the category of server-side code. So the application server-side code was responsible for performing all these activities and then delivering some data to the browser, the client side, and the client's responsibility was just to render the information and present it to the user and handle the interactions. With Web 2.0 and Ajax and Flex and a number of other such technologies, the whole thin line that was the responsibility of the browser that has shifted far left. That means now a number of things that earlier were part of server-side code of the application now became part of the client-side code of the application. Server-side responsibility still remains to present the data, to prepare and send the data, but it's now totally client-side, the browser-side code of the application to handle the interaction, present a rich internet application, present a rich interactive UI to the end user. And with HTML5, the thin line that was there has diminished even further. With HTML5, we can create applications that reside entirely inside the browser. They don't need any web interaction. You can have a file, have all your application code inside the HTML file, open it in web browser, the same way that I'm doing right now for this for the presentation. It's an HTML5 based presentation. It's not interacting with anything on the server. It's residing completely inside the browser. And it's giving me a rich internet experience, right? So with the emergence of all these technologies, the responsibility of browser for presenting and preparing the application for the end user has grown. Are we really caring about doing a performance analysis of the code that gets executed by the browser? This is another very interesting graph. The stat of the sale of internet devices globally. And you can see from this graph that in 2013, by end of 2013, the overall sale of smartphones and tablets, the handheld devices, would be twice as more as the sale of personal computers. Why does that impact the user experience? Well, compared to personal computers, the smartphones and mobile devices, these tablets, the handheld devices have far less amount of resources. The CPU cycles, the available memory. So the browsers running on smartphone would have less resources to process the information compared to browser running on a personal computer, which might have an i5 or an i7 processor with about 10 or 20 GB of RAM. So essentially, the amount of resources available to the browser in mobile devices is far less, but overall, the users are moving towards that paradigm. They are moving towards using web applications and mobile applications on their mobile handheld devices. So experience on those devices has to be optimal for such users. 2013 has been termed as the year of responsive web design. What does that mean? Well, a couple of years ago, the web developers had the choice of building two different versions of the application front end. One for the personal computers, the system that have bigger form factor, and the other for smartphones and mobile devices and tablets. Essentially the system which had smaller form factor. And because they had the choice of building two different versions, they could decide what features can be compromised in the mobile version of the app to enhance the user experience, in general to speed up the UI. Because in mobile there's less amount of resources. But in 2013, the developers are really trying to build a single version of the application front end which is responsive enough that it displays consistently across all different form factors of the application. This reduces the overall development and maintenance effort of two different versions of the front end. But this opens up a very important problem, that is that if we have similar feature sets in the mobile application compared to personal computers, then we need to also make sure that we have consistent performance of the application, right? Now let us try to understand how we can implement this as a practical solution in our day-to-day testing cycles. First and foremost thing would be to make this part of a standard test automation execution. And for that, the very first and primary thing we can do is we can have these tests ready and make them execute build by build. What would that give us? Imagine you are in the first sprint of an application and there's one page which has two pages, two features on the same page, the UI features on that page. You create a UX benchmarking test. You have the reports available for that particular page for that sprint. In the next sprint, the developer decides to add another feature to the same page. When you rerun these tests again on that build of the next sprint, you can clearly determine if addition of newer features on the same page has enhanced the performance or whether it has degraded the performance of the overall performance of the page, of the existing features in there. So you can answer a bunch of questions like, how much is enough in a single web page? Do I really need to scatter my functionality or make it concise that it is available in a single page, or do I should split them into multiple pages and have that kind of a user experience? So you would be able to answer such questions through when you have these tests running build by build. And you can also run this against and compare different platform configurations. Compatibility matrix, you have your compatibility matrix, but you also need to make sure that the performance of the UI remains consistent across all different supported means of accessing your application. Right? If you have a mobile app and you have a web version of the same app, you would obviously want the same kind of experience for the two users coming in from two different ends of your application. And how do you make sure that you have that consistent behavior? You do a UX benchmarking and have a comparative report. You can compare the performance of these two applications under two environments, and then you can take a call. Whether I have to do an optimization for one particular version, whether I have to split it, or however the optimization is required, we have to do that optimization so that the overall experience is good for the end user. In fact, we did this in one of a project that we executed at QAIT. It was called as Oyala. It's a Flash-based video player, and we built a very similar test, a benchmarking test for the player, and the intention was to identify how much time it takes for the player to start playing the video when we click on the play button. So we had a test in place, and we were running that test build by build, and the developers were trying to optimize the time it takes for the play to actually begin once you click on the play button. And that was only possible by having these kind of tests in place. And it's all automation, it's not load testing as of now. A secondary approach could be to integrate these kind of tests alongside your load testing strategy. Make it a hybrid approach. You have your load test running, and you can have your UI benchmarking test running alongside your load tests. And then you can have a comparative analysis. With the load test, the performance test, you can get the HTTP performance. With benchmarking test, the UI benchmarking test, UX benchmarking test, you get the UI performance. Performance of the application code that runs inside the browser, or the app side, the client side code. And then you can have a comparative analysis. Let me show you a graph. Look at this. We executed a test for IMDb app. And we did a load test of 500 users. And while these tests were executing, we did an execution of 500 iterations of UI benchmarking tests for the same set of transactions. So with load test, we get the HTTP response time, the HTTP performance of the application, and we can figure out the average over 500 set of iterations. And we can do the same thing for our UI, the time that we recorded inside the browser. And the render time would be the average of in-browser profile time minus the average of load time. You can figure out how you want to analyze this data, how you can do a 90 percentile graph, and however you want to analyze the data. Essentially, the idea is to be able to have some form of data, measurable data, to identify the UI, UX performance, UX experience in terms of the performance of the application on the client side. To conclude this presentation, I'd like to say is that we can build open source solutions that do this kind of job of doing UX profiling of your client-side applications. With the emergence of mobile apps, which run entirely on mobile, but they still have a web version of those apps available. So you essentially have two different versions. One is a web version and another is a mobile version running inside the mobile. Doing these kind of exercises have become more relevant. Because the browsers, the client-side code has to do a lot more than what it was supposed to do a decade ago. And we have to make sure that the experience that is being provided from the browser is optimum for the end user. And it is measurable. With these kind of tests, the kind of solution that we demonstrated is built entirely on open source solutions. So we have a Selenium-based framework, and we enhance that framework to be able to do this kind of work. Because it's a Selenium-based framework, I can run the same test on multiple different configurations on mobile devices as well. Right? So I can get a comparative result of the test running on different devices. So I can compare the performance of my app on different devices, and then take a call on which devices I'd like to support, on which devices I know we require more optimization. This kind of activity must be done for your thick and thin desktop-based applications as well, not just your mobile app, not just your web apps running in browser, but also your thick and thin desktop apps as well. With this, I'm done and open for any questions. Yes, we have.
First question is that you said that you use the open source.
Yes.
But you didn't mention the name.
I'm sorry?
What is the open source code you have used?
We have primarily used Selenium. There are a bunch of Java and Ruby-based libraries that are entirely open source, and we have built on top of them.
And second one, you said that open source and you build it on the top of it.
I'm sorry, you're not audible.
Okay. You have used the open source tool and you build that customization UI.
Right. We did not customize the tools as such, but we built a framework integrating all those tools together so that we have the right amount of functionality inside what we develop.
Do we have any commercial tool which does the same thing?
As of now, I don't know a commercial tool that would directly do this kind of activity for you. But since you have test automation tools and this is actually a test automation activity, you can have any commercial tool doing the same kind of thing for you. You can have Qtp do your UX benchmarking. In fact, you can integrate Qtp with load tests as well. You can have a GUI script created in Qtp and have it run through load runner. That kind of would do the same thing. So the problem there is the number of licenses you require to run that amount of tests.
Okay, one question I have.
Yeah.
So if I conclude this, ultimately we are trying to achieve the performance and load testing through your solution of test automation. Is that correct?
Not load testing, but trying to see that the in-browser performance of the application, whether that is proper, whether that can be measured, and if it can be measured, whether that can be optimized for an application or not.
So is it more optimizable or more effective than load test reports, which has more?
This has to go alongside the load test. So load test solves your HTTP side of the problems, your application server side of the problem, slowness from the application server. But what about the slowness that are because of the kind of rich internet UI that you have built to give a very rich experience to the end user? That also adds up to the slowness of the application, right? How do you account for that? So these kind of activities would essentially give you the tools to account those slownesses. And then you can, alongside your load test, you can have an integrated analysis.
So primarily the load test, and you can capture this.
Yes. In fact, in case of Oyala, we didn't do a load test. We entirely did a UI benchmarking test. It was entirely the front end side of it. Client side.
Okay, thank you.
I heard that HP having a web diagnosis.
Okay.
Is it a same?
I'm not sure about web diagnosis, but we have a bunch of tools out there like PageSpeed, Google PageSpeed and Yahoo, YSlow and things like that. What these tools do is, they would give you the amount of time that it takes for the page to download completely. But there's a lot of interaction and a lot of execution that is required after the things are downloaded inside the browser. If whatever you talk about, if it does that kind of thing, it is just one side of the story. The other side is when users start to perform activities inside the application, where it becomes a user experience for the end user, not just downloading and seeing it. Okay?
I have a question.
Yeah.
You are talking about the browser rendering timeline, which is very, very critical part. How about the device capability and form factors, which is going to add some more influence? Say, for example, the same application, optimized application, may work very fine for a particular device with a, say, higher capacity or higher form factor, whereas the lower end of the same device may not be giving it in the same moment. Am I right?
That absolutely can happen. And but these kind of exercises would essentially give you that measurable component. Okay, so I definitely know that this is the amount of time that it is slow compared to another device. It totally depends on how you want to grasp the data for doing that analysis and what kind of conclusions you want to draw from it. Right? If you want to compare two different devices, then you can use this kind of solution to compare it. But if you are targeting a specific device and you just want to optimize the performance on that device, you have to do it build by build. Do some optimization, record the results, then run the test, have the results available, compare it with the older test results, and do it in a sequential manner.
Hi, Ramandeep. Sandeep here. My question is just add on to the previous question. Is that browser performance depending on the many other situations like network congestion and your device configuration.
Right.
So how will you successfully conclude that this is not due to the network problem or page load time is increasing or rendering time is increasing?
Exactly. In fact, that is why we built that particular extension that intercepts the HTTP transaction while these scripts are running inside the browser. So let me just show you that graph. I wish this page was open, but essentially you have two different data coming in from this test: the HTTP transaction time and the in-browser time. So you can eliminate the HTTP transaction time from the overall in-browser time. So you just get the browser at a time. Again, this is theoretical. It is not actually that simple. You have to do far more calculation besides this. Like in some cases, you have to make sure that you also capture the CPU usage while doing a particular test. You also capture the version memory of the browser while doing the test, right? And in some cases, you need to be very specific in identifying what activities in the application that you want to time, right? And those activities may or may not have HTTP communication for the user to get the response back. So accordingly, you take a call whether the HTTP data and the bandwidth and the lag time and the throttle, whatever it is, that makes a impact in your overall analysis account.
I think that would be the last question because we are running out of time.
I think we can take it offline.
As an end user, while interacting with web pages, you told that HTTP, right?
I'm sorry?
HTTP.
Yes.
Use some HTTP protocols. Means as an end user, while you're interacting with the Facebook web page, it will consider some protocols, right? From web page to web browser and
If I understand your question correctly, you want to know what kind of protocols are